LJC Short Talks. We've got two fantastic speakers for you today. My name's Helen Scott. I'm also an aspiring speaker, and Barry asked me to step in and host this one today because he's unable to make it, and I foolishly said I want to try hosting. So here I am, because that's how things go with Barry. You make a suggestion and then it happens. So without further ado, I would love to introduce you to our first speaker today. So we have Sarah Young up first. She's going to be talking to you today about understanding conflict and how science and psychology can change how we collaborate. So a little bit of background on Sarah. She is a cultural historian turned infrastructure developer and aspiring chief joy officer. That they have capitals. I'm going to be asking her what exactly that is later. She's an XP and reliability engineering enthusiast and currently working as a site reliability engineer at Government Digital Service. So I'm very much looking forward to this one. Over to you, Sarah.
Cool. All right, I will share my screen. Let's see if all the tech gremlins are out bag. Can you all see a fancy schmancy slides? Nice. Okay, let's kick this off. Okay, so hi everyone and welcome to Understanding Conflict. I'm going to start with some introductions as well, even though Helen did a fabulous intro just now. As Helen mentioned, I come from a humanities background. I am a cultural historian by training at least. And so I did a bit of psychology when I was at university, and that kind of fueled an interest in how the mind works and how people communicate. And a few years back when I was working at a company that did extreme programming and we did a lot of collaboration, I decided to do a deep dive into conflict and psychology because I was just really curious about it. So this talk is based partly on that course, but also on subsequent reading I did afterwards. Today we're going to be talking about four things. What is conflict? And why you should really care about anything that I'm about to say. And then going a little bit into understanding the science of stress, which lays down the foundation for understanding the psychology of conflict. And finally, we're going to go into understanding how we can choose to respond to conflict. And throughout this, I'm going to give little tips about basically how to do conflict effectively, which hopefully you can use in your day-to-day lives. So the three things that you need to remember from this talk, and you could walk away right now and just say, blah. You have to remember, breathe, ask, and choose. I'll go into all of these in a bit, but I want to sort of dip your toes in the water, and these are the three things that you need to remember, and I'll be covering them as we go along. So first up, housekeeping on conflict. When I talk about conflict in this talk, I'm not speaking about bullying, I'm not speaking about harassment, I'm not speaking about violence. It's just kind of your bog standard interpersonal office conflict, fighting over Emacs versus Vim, or whether you should use this database or another one. It's not, everything else is sort of above my pay grade effectively. Okay, let's dive in. So many of us grow up believing that conflict is bad, it's uncomfortable, we don't like it, it's toxic, it's a break in communication. When it starts happening in a room, everyone kind of goes quiet because the two people who are having a conflict are really kind of going at each other, and it's just not fun. The problem with that attitude is that we communicate so much as software developers. We pair program, we collaborate, we just discuss tech choices, and invariably conflict will happen. But because we think it's bad and we've not really investigated tools for how we want to just handle conflict, it means that we often repress what we're feeling, or maybe we even escalate, we start a yelling match, and it can have an impact on our working relationships. We lose trust with each other, and the work, the actual software development work, becomes harder. Now, personally, I think that there's a solution, and the solution is that we need to rethink what we know about conflict and how we react to it. And that's sort of what I want to go in today, and this is why you should care. Ultimately, I want to get us to a point where we believe that conflict is normal and it can be a catalyst for change. This is something from the field of conflict transformation. It's the belief that instead of conflict as being a break from normal communication, conflict is a type of communication, and it can be a catalyst for change. That means that we as people grow from what we can learn about, we'll learn from conflict, but also what we can learn about ourselves, the people who are in conflict with, and it can potentially change our relationship, and in the world of hippy-dippy conflict transformation, change the world. However, in order to get to this kumbaya space, we need to understand the science of stress and basically how the body reacts in a stress situation, because it's really, really fundamental. Okay, so this is the stress response articulated in the very scientifically reliable way of emojis. You have a threat, and this is based on evolution. And so like millennia ago, there would be a tiger. We as humans or proto-humans would sense the tiger. We would send a message to a part of our brain called the amygdala, which would say, ah, panic, it's a tiger, red alert, and then send another message to the rest of the body to freak out. So increase your heart rate, you can contract certain muscles, your breathing increases, blood pressure increases, you sweat, all that kind of stuff. Now, this process engages what's called the parasympathetic nervous system. It's your fight, flight, or freeze, and is completely involuntary. It happens in nanoseconds. You don't really recognize that it's going on. So this is the threat system that we had millennia ago. Not a lot has changed since then in terms of the actual stress system. What's changed is how or what the brain perceives as a threat. So there are fewer tigers walking around our offices, right? But the stress response is the same, right? Your brain, well, you sense a potential threat that sends a message to the amygdala. The amygdala says, yeah, no, that checks out, that's a threat. I'm going to push the panic button, and you have a stress response, right? It's involuntary, as I said. So what can you do in this situation? Well, the number one thing that you can do is breathe slowly and focusing on the exhale. This will engage your sympathetic nervous system. It will slow your heart rate down. It engages a nerve called the vagus nerve that goes from the base of your skull to your gut, and sort of sends a calming message to pretty much all parts of your body. It also sends a message to your brain to calm down. It's a physiological message from the body to the brain to chill out. The other thing that it does, and one of the reasons why it really works, is that it engages something called the prefrontal cortex. So the amygdala, which we just met, it reacts really quickly, and that's what it's meant to do. It's meant to protect us, right? But it jumps to conclusions. The prefrontal cortex, which is a different part of the brain, sort of in the front part, it needs time to catch up, and its job is emotional regulation, metacognitive thinking, sort of like communication, language, that type of stuff. If you've read the book Thinking Fast or Thinking Slow, this is that territory. The prefrontal cortex is there to play catch up, to process everything that the amygdala is alerting on. So the prefrontal cortex is really, really important, which is why breathing matters. Not only are you sending a physiological sign to your body to just calm down, it also gives your brain time to catch up, so that the amygdala has said, hey, this is a tiger. But your prefrontal cortex in a bit of time will say, no, not a tiger, zebra in the sunset. Don't worry, no need to panic, it's okay. Right, that is how you respond to conflict. And breathing, by the way, I know I'm going to sound like a yoga teacher or mindfulness coach here. This is the most important thing that you can do in a conflict, is just breathe and breathe through it slowly, focusing on the exhale. Take this one thing from the talk, is learn how to breathe. And when you're feeling stressed, do the breathing. Okay. So we know how the body responds to stress. We've zipped through that. Let's build on that knowledge to get a better understanding of the psychology, the underlying psychology of what happens in a conflict. So we know that there are threats. They are no longer tigers, but they happen in social situations, right? And we know that a threat triggers a stress response. The other thing it can trigger is strong emotions, right? We react strongly when we feel threatened. And often why we are reacting strongly is because there's a deeper psychological issue at play, right? Psychologists have identified three main deeper issues that when the brain thinks they're being threatened, it will respond with a stress response and strong emotion. So those three things are needs, values, and identities. Needs is a psychological condition which is required for human stability and growth. Think Maslow's human needs, that like hierarchy, that triangle that you see with Wi-Fi at the very bottom. it's fundamental to how we survive as humans. And if you deny a human any one of these things, eventually you're kind of going to go through a psychological breakdown. Values, this is a bit, in the context of conflict, it's a bit more complicated. It's a mental process which is both cognitive and emotional. I'm going to take fairness as an example here. So fairness is a concept, it's a cognitive concept, right? But each of us have an individual emotional relationship to that concept. So for example, I am a younger sibling. I am a younger sister with an older brother. Fairness was a really, really, really big part of my childhood. Making sure that my brother did not get an ounce of juice more than I did was my #1 priority at age 4. I have very strong feelings about fairness even now in my 30s. And that's because it's a value that I hold dear to me because of my experience growing up as a baby sister. The third one is identities. These are the traits, characteristics, social relations, roles, and social group memberships that define us as individuals. Often psychologists talk about this as the story we tell ourselves about ourselves. You know, I am an engineer. I'm a good parent. I'm a smart person. It's really important for us psychologically to have a strong sense of self-worth and identity. And if at any point our identity or this story, this narrative that we tell ourselves about ourselves is threatened or perceived to be threatened, we will react with a stress response. So what does this all mean in the context of conflict? Well, we all have these deeper issues, and often they're the same. They're very relatable, right? But we have different interests arising from those issues, and ultimately we choose different positions to meet those issues and those interests, right? The book has a few examples. I got this quote from the book, Changing the Conversation. It's really excellent. It's hard to find, but very, very good. And what does this look like in sort of a day-to-day environment? So we'll take this one example. We've got a person, they have the deeper issues, their identity as an engineer. They have an interest in being seen as technically curious. And so in some meeting, they're going to say, that design doesn't make sense. Why do it that way? It's horrible, right? I'm really curious. Why do it in a really stupid way? Their colleague, who also wants to identify as an engineer, but is interested in being viewed as an authority figure, is going to respond and say, well, I feel kind of threatened. Why are you asking a stupid question? How dare you question my judgment, right? It's a potential conflict. Ultimately, a conflict can look like this, where the two positions look like they're in complete opposition, that there's no place of commonality, there's no common ground. The interests, again, may be different, but fundamentally, the deeper issues are where there's the potential for commonality. Right? In a conflict, it's important to get to the root cause, to dig deep into those issues, the underlying foundational psychological reason that a person is responding with strong feelings and potentially a stress response. This is the place of compassion, empathy, common ground, and ultimately compromise. So in that perspective example I just gave, imagine 24 hours later, you know, and the person comes up and says, hey, you know, I was kind of surprised at how frustrated or angry you seemed in that meeting when I asked about the design. Can you tell me what's going on? Yeah, I really didn't appreciate how you were questioning my authority. You know, I was the first hire in this company. You know, it's important that people see me and the technical decisions I make as, you know, a valid and trustworthy thing. This role of authority figure is important to me. Oh, I had no idea. You know what? I'm sorry about that. How can I ask questions about the work that you do in a context that doesn't feel as threatening? Okay, yeah, maybe just pull me aside afterwards and ask me privately. Would that work for you? Yeah, totally. Right, this is a hunky-dory, happy-go-lucky, zero actual human conversation, but you get the picture. If we get to the deeper issue about identity, about people needing to feel like either they belong or who they are, then we have greater potential for a compromise and a way forward. So this is why asking is so important. It gets us closer to understanding the deep issue, both in ourselves and potentially in other people. The first step is to ask ourselves why we feel strongly to a particular issue. Why are we reacting in anger, frustration, upsetness, sadness? Check in with others about what's going on. Maybe give it a bit of time. When someone's angry, they don't necessarily want you to come up and be like, hey, tell me about all the things going on inside, right? Actively listen, be vulnerable, practice self-awareness. Asking is the first step to listening, and listening is the beginning to finding common ground. Okay. Right, so conflict in real life can be intimidating, but it doesn't necessarily have to be, right? We actually have a bit more choice than we realize. And learning how to respond to conflict, I think, is a really, really effective tool to be able to handle it in real life. We've gone over how to reduce the body's stress response, right? So breathing slowly, giving your prefrontal cortex time to catch up. We've gone into asking and why it's important to listen to deeper issues, both in ourselves and in other people. What is the next step? Going back a little tiny bit, part of the problem with believing that conflict is bad and avoiding it and not wanting to learn more about it is it means that we default to learned behavior, a learned response to conflict. And that means we don't realize that we have a choice in how we respond. And there are actually techniques to help us figure out how best to engage in conflict in the moment. To that end, I'm introducing you to the 5 conflict styles. These were developed by psychologists in the 1970s. They're based on patterns of behavior that the psychologists recognized in a bunch of data and research. We use all of them, but gravitate towards one. Often the one that we gravitate towards has a lot to do with how we grew up, who we grew up with, the cultures that we moved through, and things like that. Can anyone guess what the 5th one is? I've not labeled it.
I can take a guess.
Go for it, Helen.
Compromise?
Perfect.
Yes.
Right? Okay, so now let's unpack these little tiny bits.
Imran got it as well.
Oh, I can't see the chat, so sorry. The best way to conceptualize these is through, I think, an analogy. So imagine that you've had 2 friends come over to your house for a movie. It's now 9 p.m. and you're all very hungry, but you need to decide what to eat. If you use the competing style reaction to conflict, that means that you're steamrolling your 2 other friends. We are having pizza. I don't care what either of you 2 say. I don't care about our relationship. I just want to have dinner and I want it to be pizza. Screw both of you. If you're collaborating, it means that you chat for an hour, go over the pros and cons of each various cuisine that all 3 of you want, and ultimately you make 3 separate orders to Deliveroo, 1 for pizza, 1 for sushi, and 1 for curry, right? Each person gets what they want. It takes time, but everyone's happy and the relationship hasn't been damaged. Accommodating could be, yeah, I don't really care if we have pizza or not. That's really fine. I had wanted burritos, but you know what? You seem like you're really craving pizza right now. So let's just get pizza, right? Avoiding is your one friend who just runs for the door at any like glimmer of conflict, any hint that there might be a slight debate. They are out of here. They are the ones who go to the bathroom while you and your other friend are debating between burritos and pizza. And compromise is the halfway happy. That's when someone suggests, hey, you know what? You want curry, you want pizza. I don't particularly care. So why don't we go to this new place that does pizza curry or curry pizza? That is the halfway happy. Now, none of these styles is particularly bad. Each has their own pro and con, and it's about knowing when to use them, right? In what context, and how do we choose? Well, conflict transformation has given us a handy dandy system, which I'm going to introduce to you to. So in a conflict, we have a what. What is the thing that we are in conflict about? What is the issue? What is the goal? And sometimes we really care about the issue. Sometimes we don't. Sometimes it's a low concern, don't really care. Sometimes it's a high concern. This is really important to me. We also have a who in a conversation. Who are we fighting with? And this is a little bit more complicated. The low concern means that we don't care much about the impact of the conflict on our relationship. Sometimes that's because we believe the relationship is resilient enough to withstand tension. Other times, we just don't care about the person. Maybe they're a stranger. Maybe they're someone that you're not going to see again. Maybe you don't like them. All very, very real scenarios. Using this sort of XY axis, we can sort of map those different conflict styles into these contexts. Like, how much do we care about the issue? How much do we care about the person or relationship? What does this look like? So A competing style can be more effective. Oh, I can hear someone. Is there a question? No.
I think it's just someone off mute. Carry on.
Oh, cool. Yeah. Competing style can be most effective when the issue is super important, if it's really time sensitive, if it's an emergency, if the outcome is critical, and you don't mind steamrolling everybody around you. That's fine, right? If this is the only style of conflict that you use, you might get a bit of a reputation for a jerk because you're steamrolling individuals. If collaboration is really important on your team, maybe think about using this selectively. Avoiding, that's when you don't care about the issue and you just don't want to engage in the relationship. You're just getting out of there. You don't want to have anything. Conflict is just too uncomfortable. It can be useful if the issue really is insignificant and maybe you don't know the person. If someone's just stepped on your toe on the tube, it doesn't matter. It's going to be fine. Doesn't hurt that much. If this is the only tool that people use, you run the risk of never really fighting for what you believe in, especially if actually the issue does matter to you, right? And it can over time become a bit emotionally corrosive. Collaborating. This one gets a lot of fanfare, but I think there are downsides, which you can kind of tell from the example I gave. Having to wait an hour for dinner and making like 3 separate Deliveroo orders is a pain in the butt, right? It takes a long time to do collaboration because in this context, each person's position has equal value and no one is going to be giving ground. They are all interested in maintaining the relationships, but also getting what they want, right? So again, it's fine to use this approach. I have used it, in professional setting. It just takes a long time. Accommodating. This one gets a bit of a bad rap as, being a pushover, but I actually think it's kind of useful. This is when we care about the relationship a heck of a lot and we don't really care about the issue. I found when pairing, once I started using this kind of conflict style, when we were having disagreements on how to go forward in code, I actually learned a heck of a lot. Because at the end of the day, I didn't really care too much about the technical approach we were taking. And often I'd see someone design something that I'd never thought of, or we would both learn something about how an approach definitely didn't work. And it was I cared more about maintaining that pairing relationship and that social bond than the particular issue. Also, like avoiding, however, if this is the only conflict style that the person uses, over time, it can be, again, emotionally corrosive because that stereotype of a pushover kind of lives up to itself. If you accommodate someone on something that you really believe in, an issue that you really care about, then it doesn't feel so good after a while. Okay. Finally, there's a halfway happy. This is a compromise. This is I give something and I get something, you give something and you get something. This is this is the idealized way of doing it. And I think from my experience, it can be like a fairly effective tool, but that's not to say that the other 4 aren't also effective in certain contexts. Cool. So the point of all of this is that we can choose how we respond to conflict. We are not locked into a particular approach. Also, our choice can have an impact on ourselves and the people we work with. I cannot begin to tell you how helpful it has been to have that internal sort of mental calculus of how much do I care about the issue that I'm fighting for, and how much do I care about the relationship with the person I'm fighting. Once I do an internal check on that, I'm like, oh, hey, I don't really care about this. I'm going to back down because it doesn't really matter. Or, oh, wait, no, this is actually really, really important to me. And I also really care about the person. Let's schedule an hour to kind of hash this out together because we need to come to some kind of agreement, right? It saves me a heck of a lot of time to know when to use a particular style in a given context. And also means that my relationships with people become a little bit deeper. All right, so let's put this all together. So breathing is the first step in a conflict. Slowly focusing on the exhale, slows your body down, gives you time to process. This is the first step when you feel you're being mindful and you feel yourself getting kind of agitated. Step 1 is breathe, walk away, go make a cup of tea. It's perfectly fine to leave a conversation that you feel really enraged about. Put yourself on mute other people, right? That's okay too. Say that you have to go to the toilet. I do that all the time, right? Or, there's someone at the door. Anything to give your body time to move from that state of stress to a state of calm, right? Second, ask yourself the deeper issue at play. Which deeper issue is being threatened potentially, or you feel it's being threatened? Is it a value? Is it a need? Is it a sense of identity, right? That is the first step, to start with yourself. Then begin to ask the person that you're in conflict about their reaction, and listen with curiosity, because that opens the door for compassion and compromise. I cannot tell you the times I've gone back to a person and said, hey, how you reacted, that kind of confused me. Can you help me understand why you were frustrated? And then I learned something new about them. I was like, wow, I had no idea that the way I was phrasing this was bothering you. And our relationship deepened because this person, one, I was vulnerable, and two, they were vulnerable. And we were able to mend that bond and then move forward. Finally, choose. Know that you have a choice is really empowering when it comes to conflict. It means that we can use a style that's appropriate for the context because we've assessed how we feel about the issue and our relationship. Ultimately, I think that this can bring us closer to the idea in conflict transformation that conflict is normal and it can be a catalyst for change. So, thank you. And credit to this new thing I found called Slides Go, which make the best slides on the face of the planet. I think we might have time for questions, Helen?
Yep, couple of minutes for questions. Thank you very
Cool.
much, Sarah. Thank you.
I know questions can feel a bit intimidating, especially over Zoom. I have some pre-baked ones that I made if you're interested, or you can ask me whatever's on your mind.
Throw it open to questions then.
Hi, it's Andrea. Can you guys?
Yep, go for it, Andrea.
Yeah, okay. For me, it's not exactly. First of all, it was amazing. I loved it, and it's more like a comment, not a question. But I would like to know if you agree with it, Sarah. The thing is about it's perfect that you said that we should go away, breathe, and ask first to ourselves, and then ask to the person that we have the conflict with. But I think that because many of us are full-time at home now because of the COVID, we are not in the office together. So this, for many people, this makes the communication a bit harder because they are not there in the office together. So one thing that I learned, and I think that's better, is if you have to talk to someone, prefer doing this, maybe set up a video call, instead of trying to write it, communicate via email or instant messengers. I think that it's very important, preferable with a camera, because then you can see the reaction. What do you think about that?
Absolutely. Absolutely. The times I've had to go to people after I had a strong reaction to something someone said, I've done it over the phone or over a video. There's so much that is conveyed in nonverbal cues and intonation, things like that, and just matching the two up. I think it's really important to do that, actually have a conversation, not in a text space, but in a verbal space.
Great, thanks.
Wonderful, thank you. We are out of time for yourself, Sarah, but I think I'm probably speaking for everyone on the call. That was really informative. I certainly got a lot from it in terms of situations that retrospectively I probably could have handled differently. So thank you very much for sharing that. All right, on to our second speaker for the day. So next up we have Matthew Lodge. So Matthew is going to be doing a talk called Using Reinforcement Learning to Beat Go Masters and Write Java Unit Tests. That's the bit I'm particularly excited about. So Matthew Lodge is currently CEO of Diffblue, which is an AI for code startup. Earlier in his career, he built compilers and distributed systems for projects like the International Space Station. Very cool. And the Zoom recording has just taken Matthew's bio away from me. He's also helped to connect 6 countries to the internet for the first time and managed a 630 million router product line at Cisco. So I feel you're very well qualified for this, Matthew. Over to you.
Great, thank you very much. And sorry for a premature sharing there, I think.
It's my bad.
So, sorry about that. All right, so now for something completely different. I love Sarah's talk, but we're going to talk about a technical topic now. And essentially this talk in a nutshell is, if you think about the way that artificial intelligence or machine learning get more specific, can find the best go move, then in the same way, the same machine learning or AI can search for the best unit test for Java code. And essentially, that's what I'm going to talk to you about today. This is what Diffblue does with our tool for automatically writing Java unit tests. So if we just think about how we program, how do we write a program? It's pretty straightforward when it's easy to figure out how to essentially decompose the problem into smaller pieces and assemble those and to form a logical result. And so, sort of integer math is a really good example of that. It's very easy to do maths like this, where you can decompose the expression into the different forms and write a program. And you're probably thinking, why is he telling me this? This is just obvious, right? Stepwise refinement, we all learned how to do that. Well, the problem is that there are some challenges, some problems that are highly resistant to that form of decomposition and that approach to building an algorithm to solve them. And so image recognition is a classic example of this. So, asking the question, what's in this picture? It's really not obvious how to decompose that. And so the idea with machine learning and AI is that instead of trying to break the problem down logically into an algorithm, you can use statistical methods to iterate on a model that essentially learns how to relate the input to the output. And so for image recognition, we're very familiar now with things like neural networks and techniques like that, that essentially can take the input image and then relate it to a set of tags, right? So from the input image, you get a collection of tags that represent that image. And in the case of most image recognition algorithms, they'll give you a percentage. One of the best kept secrets of this is that percentage is not actually predictive or not statistically valid, but it will give you a confidence interval. And so it will say 91%, I think there's a cat in this picture, 86% sure there's a dog, and so on. And it'll get some of these things wrong, like pebbles and bread. But essentially, what's behind that is a model that has learned how to relate input to output by being exposed to lots and lots of examples. And it's really interesting to note that this approach has been incredibly successful in very specific domains. So if you think about machine learning models for computer vision, they basically have beaten every algorithm handcrafted by a human in the last 50 years, which is really pretty remarkable. And you can see sort of like the history of algorithms to do image recognition on the left-hand side there, starting in the 1960s. And it was all about that, taking that decompositional approach, right? So how do you decompose the image into edges and lines and polygons and space, textures, shading, all those things, right? So very classic human approach to solving the problem. So I try and break everything down, and then I try and reassemble all the pieces back together by building 3D reconstructions, and I segment the space. None of it worked. None of it worked well enough that you could write a generalized image recognition algorithm really until statistical methods were started to be introduced in the sort of 2000s. And then you can see on the right-hand side the progression of ImageNet. So ImageNet is kind of like the gold standard in image recognition algorithms. There's a competition that used to run every year for the most accurate computer image recognition system. And you can see from 2011 to 2012, there was this enormous improvement, 10% improvement in accuracy. That was when they first started using convolutional neural networks. So that was a big, big difference. And you can see that the steps after that get smaller. There weren't really any significant breakthroughs like CNNs beyond that. They just got better and better at refining the algorithm until you got to the point in 2015 when the algorithm is better than humans at recognizing images when trained on a data set taken from the internet. It's a labeled data set of internet images. So AI in some ways is poorly named in the sense that it is not artificial, it's very real. It solves real problems that programmers find hard to reach, but it is also not intelligent. It is just maths, right? These are not your future robot overlords. It is just maths. So artificial intelligence and machine learning techniques are very useful, particularly useful when it's unclear how to link the input to the output. It's not obvious what the algorithm should be. In fact, it's very difficult to figure out what the algorithm should be. That's when it's really useful. So there are two forms of machine learning. Supervised learning is the one that we've all got very familiar with, where you have a labeled data set. And so this is ImageNet is an example of this. So the training set, typically you break the data into two. You have a training set and then you have a test set, because you need to know how good your model is. So you need some data, some existing labeled data to test it out with. So you have the training set, and essentially what you're doing is, in the case of ImageNet, you're showing it lots of labeled images, and you're saying, well, for this image, here's what's in it, and then for this next image, here's what's in it. And you tweak the weights in that statistical model over time as you show it lots and lots of examples. And so the algorithm essentially adjusts itself, adjusts all of those weights to link input to output. And there's lots of detail we could get into about exactly how that works, how many layers there are in the model, why does it matter how many layers there are. I'm not going to go into any of that today, but the output from this essentially is a prediction model, which you then run your test set against to find out how good is it, and does it identify things correctly. And eventually you end up with a trained model, which you can then use for inference. So the actual process of recognizing images that the algorithm has not seen before. Very important to note that if you don't show the algorithm, in the case of ImageNet, if you don't show it any examples of puppies, it will not be able to recognize puppies, right? So this is not magical. You have to show that the model examples of the things that you want to recognize. Unsupervised learning is very different. So instead of having this sort of training phase that happens in advance, unsupervised learning basically says, well, we don't have a labeled data set. So instead, we're going to do that learning process on the fly by looking at real examples of data. And essentially what you have is you start out with a model, your best guess. Actually, it actually turns out it doesn't matter how accurate that is to begin with. You apply the model to the environment, whatever the environment might be. In the case of AlphaGo, the environment is the board in the game of Go. And you apply that, you see what change happens, you observe the change to the environment, you evaluate, is that taking me closer or further away from my goal? And so that's the reward function, tells me how well are we doing so far. And then there's some kind of state update you have to generate, typically from the evaluation side, and that updates your model, you try another thing, and then you repeat. So you're learning in real time. So there is no pre-learning phase with reinforcement learning within supervised learning in general. So supervised methods need offline learning, they need training, they need a labeled data set, and they are massive, massive computational effort. So training is the biggest compute effort, but even just inference, you're talking about multiple gigaflops to run ImageNet to recognize an image. And that is still, even today with modern processors, that is still a significant amount of CPU, versus unsupervised methods where it's real-time learning. It's a real-time evaluation function you're using instead of labeled data. So you must be able to evaluate the state of the system. You must have a function that can do that for you. If you don't have that, you can't really use unsupervised learning. But the advantage is that you much, much lower computational effort because you're not having to do all of that pre-computation. You're not having to maintain a neural network. You're not building a neural network. So Google AlphaGo uses reinforcement learning as one of its key approaches to solve the problem. And the issue with Go is that it's an incredibly difficult game to automate. And this is one of the reasons why AlphaGo is such a remarkable achievement. So first of all, is that the number of possible moves is much, much bigger than chess. And I think everybody remembers Diffblue. It's famous for being the first computer program to beat a grandmaster, beat Garry Kasparov. 10 to 170 moves in Go, which is way more than in chess, is way more than the number of atoms in the universe, which is really insane. But it gets across to you that you can't brute force search the Go game space. You can't look at all the possible moves and decide which is the best one. And that's what makes it tractable by a machine learning technique. So machine learning is also very good when it's impossible to search the space, because essentially in machine learning, what you're trying to do is you're trying to make a prediction, and you're trying to build a predictive model that doesn't rely on searching, it doesn't rely on brute force, right? It's a probabilistic search of the space. So you can't guarantee to find the best move, but you can find a very, very, very good move. And essentially that's the approach that you're going to take with this kind of a thing. So big difference here. Diffblue was successful because it essentially brute forced the end game of chess. So what IBM did to make Diffblue so successful is basically built an ASIC. They built a chip that massively parallelized the search of the chess space. And so Diffblue had an opening book of moves, sort of common chess openings. So it knew all the common chess openings. And then for the mid game to the end game, it did brute force search. So it just looked at all the alternatives, picked the best one. Can't do that with Go, the space is too big. And also long-term strategy makes a big difference. What looks like a good move in the short term may turn out to be strategically a mistake. So it's very hard to tell if a move is good until later on. And so AlphaGo is doing that probabilistic search. And it uses Monte Carlo methods. And that's what we say when we want to talk about random chance. We don't say random chance. That makes it sound like we don't know what we're talking about. We say Monte Carlo methods. And so essentially what we do here is we suggest or guess some random moves that we haven't tried before. And then it does have neural networks, but it has neural networks to make predictions. So it's using reinforcement learning to find the next best move, but it uses neural networks to help it make predictions about the future. And so it has a policy neural network that predicts the next best move, and it has a value neural network that predicts who will win. Now, those sound like the same thing, but it turns out in Go they are not the same thing. And it turns out they're just picking the best move in terms of the current state of the board, and just looking one move ahead is a very bad strategy. And value neural network was trained on lots of successful Go games. And so originally they trained it on real games that happened with humans. And then the final version of AlphaGo, it was adversarial. It trained itself. So AlphaGo played itself at Go lots and lots of times and taught itself the value of that value network. So in AlphaGo, essentially what happens is that we use our Monte Carlo methods, but we roll the dice to find a new move. We make the move and then expand the future game states and look at the prediction of what's the best move, who's going to win, and then we expand the game further. And so in reinforcement learning, you're basically following a path. So if I make this move, then what's the move I should make after that? And then what's the move after that? And I'm trying to figure out, is this leading me towards a successful move or not? How are we doing that evaluation function? And if we're not doing so well, we might backtrack. And what that looks like in terms of a decision tree, and this is from the AlphaGo paper, is essentially you can see on the left-hand side here, I have a selection. Here's my game state, and I've got, I generated 2 different alternative moves I can make here. I can put this black stone just to the right of that one, or I can put this black stone just to the right of the white stone there. And then I expand this out, and I use my neural networks to basically try and figure out, am I going to win the game here? And if that doesn't work out, I can backtrack, and then I can try a different method. So essentially, reinforcement learning is helping you walk this tree of potential moves and evaluate which branches are worth going down and backtracking if necessary. So by this time, you may be wondering, what does this have to do with unit tests? And so essentially, the realization is that you can think of writing code as a search of the space of all programs. So if you think about the space of all possible test programs, if we get our Venn diagram going here, so well, we could generate lots of tests, not all of which are going to be very useful. So we want some programs that are valid and will run, and we want to evaluate a test as like coverage. How much of the code does it test? That's an important metric for us. And so you can start to see that we're refining an evaluation function here. So we want to look for high coverage. And then also we want to look for tests that developers find easy to read. All right, so essentially what we're doing, instead of searching the space of Go moves, we're searching the space of test programs, and we're doing probabilistic search. And instead of using Monte Carlo methods, we're using a little bit more directed approach to generate new possible test programs. And so essentially, test writing is the same approach as with Go. It shares many common characteristics. Obviously, the search space is exponential. There are an exponential number of potential test programs. There are lots of complex interdependencies between the program and the data itself. It's hard to tell if a test is useful. What's a useful test? High coverage, yes, but maybe does it test the things you really wanted it to test? Does it find bugs? And then, of course, there are lots of practical difficulties associated with this because the program doesn't just exist in isolation. It has to do I/O. There are frameworks. There's things like Spring, a version of control, lots and lots of things. Mocking, you want to isolate the code, so it's a unit test. So there are lots of practical issues that make this just difficult to do. So essentially what we do in Diffblue Cover is we have a test writer that will produce a candidate test for a particular method. We then run it. So this is one of the reasons why in Diffblue Cover we don't need a neural network. So remember in the AlphaGo, they used a neural network to make predictions about who's going to win the game. We don't need to make a prediction. We can just run the method we run the test against the method and see how well it does. So we don't need to make a prediction. We can find out what the actual answer is. And so that's what we do. So we run the method under test, run the test against the method, and we see what kind of coverage it gets. We say what results, side effects, a bunch of other things that we feed into our evaluation function. We have, and this is where the secret sauce is about figuring out what's the right reward, and how do we mutate the test? How do we change the test so that it becomes better? And so one of the things that we also try to do is write a test that looks like the Java that we're testing. And so then we feed that into the test writer, we produce a new version of test, and then we try this. And so essentially when we're writing tests, we're going through this loop. So for every method, we're producing test candidates, running them against the method, and then we pick the best one that we find. So why this works, if you think about an application, the issue is not that we just don't know what the application does, right? And determining intent is one of the sort of grand challenges of artificial intelligence. And so we have not solved that, and neither has anyone else. Instead, what we do is we write tests for the entire application that reflect the current behavior. So we do know how the program behaves today. And then what that means is that when you write a change to the application, a delta, a pull request, if you like, then you could run the existing tests against the proposed change, and tests that fail will either indicate a bug or they'll indicate a deliberate change to the program. So a test might fail because you've deleted that method, so it isn't there anymore. So we're trying to run a test for a method that doesn't exist, and so that test is going to fail. And so the program will say, okay, well, I know where that fails because I got rid of that. And so you just delete that test because it's not valid anymore. But the tests that are reveal changes that you did not intend to make, we call those bugs. And so that helps you fix up your code. And at the end of the whole process, you delete the tests that you don't care about anymore that are incorrect. And the reason you can get away with that is because then you can just update the test baseline. So you can use Diffblue Cover to basically regenerate the tests from the diff. We can figure out all the things that are affected, and we can just regenerate those tests. So it happens very quickly. You have a new baseline, and then for the next check-in, you can run those tests against that. So it helps you find bugs as you write code. And so you go from a process that looks like this. Obviously, this is somewhat simplified, but the idea is, you start with the code, you write a change, you do pull requests, you run the tests, and then you decide if the change is correct or not. And with Diffblue Cover, you've got this test baseline. So now you can run any test you wrote yourself. You can run the Diffblue test together and look at the results and determine, did I introduce a bug, in which case I fix my code, or in the case of the Diffblue test, if it's wrong, you can just delete it or ignore it. And then ultimately PR is approved, and then we can update test baseline on the new code base. So I have a 5-minute demonstration here. And so what I'm going to do is switch my sharing here, and I'm going to attempt to share the entire screen. And hopefully that will work for everybody so we can see what's going on. So I'm going to switch over to IntelliJ. So just so you know what you're seeing, this is IntelliJ, this is Community Edition, so IntelliJ IDEA, the free version. What I'm demonstrating to you here is a Diffblue Cover Community Edition. So this is free. you can download it as a plugin for IntelliJ IDEA. If I look in preferences and plugins for IntelliJ, you can see there it is, Community Edition. New version came out last night. This is 12.01. And so you can just install and use that. And what I have loaded in terms of a project, you can see here, is Spring PetClinic. So the Spring Java framework, for those of you who are, hopefully many of you are familiar with this. And what I'm going to do is I'm going to click on owner controller. I'm going to start writing tests because I want this demo to go as quickly as possible. So you can see here that when you've got Diffblue installed, you get a new thing on the context menu, and you can write tests. And so things are going to start to happen here. And so while it's doing that, it takes about 4 minutes in this example. So rather than have you sit here and wait for 4 minutes, I'm going to show you what we're going to go do. So Spring PetClinic is an example application that is designed to illustrate the power of the Spring framework. And so it's a web application. And so here we are on the homepage. And PetClinic is all about a fake veterinary office. And so I've got owners, I've got veterinarians, I've got pets, obviously. So I can click on find owner. If I don't type anything in, I get the list of the entire owners, and I can go take a look and see that Betty Davis has a hamster called Basil. And so what we're going to do is we're going to write some tests for this owner logic here, right? So find owners. So the first thing is, we saw what happened when I don't enter anything. So we just get the list of all of the owners. If I put something in that's not going to be found, like my own name, then we have that case, we didn't find anything. If I do Davis, if I can type it correctly, then we get 2 owners. So we get a list of 2 owners if there's more than one match. And then who else? Let's see, who else is on the list of owners? Start with blank. Let's pick, okay, black. So why don't we go search for black? That's the last case where we have when we have exactly 1 owner, then we don't just show Jeff's name, we go straight into Jeff's record in this case. So we go to the owner's record. So those are the 3 different cases that we want to test. We need to test the case when nothing is entered. We need to test the case when we don't find anything. We need to test the case when you've got multiple results that match and a single result. So the logic of the application has all those branches. And so if I look at owner controller, controllers are where this logic lives in Spring World. And so you can see here, this is what this code runs when you go to this URL on the site. And so the first thing here is if it's empty, then we go for the broadest possible search. So we've got that piece of logic here. Find owners by last name. And so we've got the no owners found case, we've got 1 owner found, we've got multiple owners found. So we need to write tests that exercise all of that logic. And IntelliJ very helpfully telling me that I've created a new file here because I've written some new tests, right? So owner controller test. This file has just popped into existence. This here is actually, these are the human written tests by the authors of PetClinic. An owner controller test has been written by Diffblue cover. So this has been written by that reinforcement learning approach I was showing you earlier. And you can see that we're starting to write tests for the various different methods in this function. So we've written a test here for just creating owners and things like that. A lot of this is not very interesting, but let's see. Oh, here we go. So here, where we're updating an owner, is one of the other things, the logic's in here. You can see that we've started to write tests now where we're going to have to create some objects. And so we're creating an owner. Her name is Jane Doe, Dr. Jane Doe. She lives in Oxford, obviously. And there's a phone number and all those other things. And so this is one of the things that we do to try and make the test as human readable as possible, in the sense that we're not using dummy data. If we see something that looks like a city, we try Oxford. If we see something that looks like a pet, we try a dog. If we see something that looks like an address, we use 42 Main Street. So we're using heuristics, and we also will try and use literals and other information from the program itself. We're trying to match up what identifiers are with the data we feed into them, just to make the test easier to read. So you're not seeing dummy data or the same data over and over and over. You're not seeing foo and var and 1 and 0. We're trying to feed in things that match exactly what the identifiers are, so the test is more readable. And so let's see, creation form, and then here we go. So now we've got some tests that are testing that find form. And so the first one essentially covers both the cases where we don't find anything. It covers the case we don't find anything. And so essentially, you can see here we've written a mock. So in this case, this mock is, again, auto-generated by Diffblue cover, and we've just basically said, well, we don't actually want to go off to the database and go find an owner. What we really want to do is just return a null, an empty list. And so that's what we do, so that we can then call that function. It gets an empty list back. So that enables us to go down the path of nothing being found. And then we have a set of asserts here. We're looking for, that this was in fact an okay, that we got one, a model size of 1 back, an attribute exists, and we go, the for URL, the next place we go in the application is back to find owners. And then we have the second example where we've got exactly one owner. So we create exactly one owner, Jane Doe, and we set up the mock to return Jane when it goes to instead of going to the database. And then we do the same thing here. We're asserting that the owner is going to be found, exactly one owner is going to be found, and that we go to the page for that owner for ID number 1 that we created up here. So we've covered that case of the form. And then the third one, we create 2 examples. And so we create 2 Jane Does because we can. It doesn't matter as long as they have different IDs, it's fine. And so what we do here is, again, set up the mock so that we return both of these owners when it comes back. And therefore, now we can check. I mean, you can see that the size is 2 and that we get the list of the 2 owners instead of going directly to the record for a particular owner. So you can see that this approach has been able to essentially find 3 tests that cover all of the logic in that particular controller. And we use the same approach for the entire program. So this is in terms of a demonstration. This is what you can get. You can go see it yourself. I will just switch back to PowerPoint. I'm running out of time here. You can go and download this. If you just go diffblue.com/CE, you can download this, try it yourself. And so I'm going to stop there so that I have time for questions.
Wonderful. Thank you, Matthew. That was really informative, and yeah, just stuff I'd never really considered about AI as well. So that was great. Thank you.
Sure.
Does anybody have any questions for Matthew in the couple of minutes that we have left? You can come off mute or pop them in the chat, whichever you prefer.
One, I'm not sure if you've thought about this, but obviously with some practices such as test-driven development and things like that, trying to write first as you code, how do you think your tool fits in with that?
Great question, Carly. We actually have a blog post that gives you the answer to that because it's a longer question I'm going to get into here. But essentially, there's a couple of different things. One is it can help you with test-driven development, and it's also a lot of our customers they might use test-driven development for new things, and the way the tool works, we can actually help you write tests. And you can compare the test that you write with the test that we write, and that's often a very informative process. And then the other thing is that we have a lot of customers where they just have very few unit tests to begin with, and rewriting everything with TDD is a complete non-starter. And so you need a way to bring up your test level for all of those things that were written before you adopted TDD.
Yeah, I've got a few challenges with that and some of the things I work on at the moment. So I can definitely see the benefit for older software. That's really interesting. Cool.
Brilliant. We have one more question in the chat, Matthew, from Michael. He asks, is it only Java?
It is only Java today, that's correct. Yes.
Brilliant.
When you're a small company, it's good to focus. So we picked Java first.
Absolutely, thank you. And Madeline has kindly shared the blog that I believe you were talking about in the chat as well. So thank you for that. And with that, we are out of time. So thank you very much to both our speakers today, Sarah and Matthew. Awesome job. And I believe Barry or Dom will be posting the recording probably towards the start of next week.
Wonderful. Thank you.
Thanks very much.
Thank you for hosting, Helen.
Thank you.
Yeah,
Bye.
thank you.
Bye-bye.